Hello, this is my perception with another scale model video. Antonio Subirats posted on my distance correction video that my camera elevation was too high, and I have to agree with him. He was right in that regard. So I've made a new model, the same scale, on a pretty much flat table, and well, again with the same values like you see here, with one exception, that's St. Helens. I use the 2539 meter value instead of the 255. It's a difference in the model in the scale of 0.1 millimeter, so well, it's not much. And you'll see that the 0.1 millimeter is really not a problem, because it's so small it won't make a difference. So this is Rainier, the scale version of it. Just playing around with the gauge because, well, it's a bit hard to see. So it's almost 4.4 centimeters tall. It's actually a bit shy of the 4.4 centimeters. It's a bit hard to see the 0. millimeter, the 10th of a millimeter value, but you can see it's almost as good as it's as good as I could get it. So St. Helens without the bulge. Again, 2.5 centimeters. The again, the 10th of a millimeter value is a bit hard to see, but it's in the ballpark. So there's the side peak. Again, just shy of 2 centimeters. Again, the 10th of a millimeter value. You see that it's just shy of 2 centimeters, so good enough. Oh, wait. This is my observation target. Again, in the gauge. It's about 3.3 millimeters high, so fine, perfectly fine with me. And now, because I have a 3D scale model for this and for the curve version, I could get the St. Helens peak width bulge and the side peak width bulge value. It's a bit less though, because I used the 2.55 centimeter value in the 3D model. So yeah, it's 0.1 millimeter higher than it should be, but well, it's still a small difference. It's still just a tiny and small difference. So, St. Helens with bulge. Again, 3 centimeters, just shy of 3.1 centimeters. It's a bit blurry. Now it's better. A bit though, a bit better. So now the side peak width bulge. .5, 2.51, somewhere around that. So, what? Setting the observer. Showing that the table is level at that point, level and at that point. Level at that point. Level and almost level at the 30 centimeter mark. Well, it's a bit off in comparison to the others, but well, it's still pretty much level. So, setting up the Rainier peak. So, 30 centimeter mark, the line I drew for it to get it pretty much aligned, and this is just to show that this is really as good as I could get it with aligned. So, sorry for the blurriness, but well, doing stuff, always keeping everything in focus is a bit difficult. So that was the side peak and St. Helens without the bulge. And now aligning the camera with the observer. With the observer target, but before. So, my camera is 197 centimeters away from the 0 point, but I had to offset the Rainier peak by 30 centimeters, so 197 centimeters minus the 30 centimeters, 160 centimeters. 167 centimeters. I guess that is the place of the sensor. Yeah. So I tried to align it with this part. So again, adjusting the height. And because I forgot it and wanted to show it, the tripod is as good a level as I could get it, and the camera is also as level as I could get it. So now it's time for this one. Just one thing. Just back. I tried to align the black line with the middle of the circle, because this circle is in the middle of the screen. It didn't. I couldn't do it perfectly because with the other observations I did, when I zoomed out or had a or I wasn't zoomed in, then I could see the target sharp, but could align it. But when I zoomed in, I could see a really big difference. So I went with zooming in, take the blurred part for granted, and tried my best to align it. It's not perfectly aligned with the observer, but it's as good as I could get it. So now this is taking over. This was just to show that the setup video and this view of the P900 are the same, because, well, tapping the right amount of time and the difference between the taps is hard to get, so, well. And now you can see above the flat plane, or with the Sidepeak and St. Helens in the flat version, it's the Rainier is a bit below St. Helens and much higher than the Sidepeak. So this is just trying to zoom in, zoom out, find the right spot to get them all be kind of in focus. So now I change the St. Helens part with the one with the bulge, and Rainier disappeared, but right about there. So now Rainier is with the bulge included. Rainier is a bit below St. Helens, St. Helens Peak, Side Peak, and, well, St. Helens Peak is still higher than Mount Rainier. Skipping up through. Yeah. So this is the part. Yeah, this is the part where I change the height. So just to see what happens if I change the height. So on the with the bulge, well, Rainier rises up, and when I lower it, Rainier goes down. So just to get to something I said earlier in the video. Wait a minute. So yeah, my camera, just with this shot. Yeah, my camera in the other video was probably a bit too high because Rainier was a bit bigger than the St. Helens Peak. So Antonio Subirats was correct. Again, to messing with the height. Ah, yeah, so this is with the P900, just to verify the distances and values again with the P900. So still 197 centimeters. Sidepeak plus St. Helens at this line. Mount Rainier, the 30 centimeter mark. Just for fun, using the flat version of St. Helens and the Sidepeak. Did I show the meter mark? Ah, close, but well, you can see that it is at 10 meters and 22 millimeters, or 2.6 millimeters, because well, the 2 meter mark is here. So if there's a 10 between the 30 at Rainier and the camera location, it has to be at a 1 meter mark. And again, messing with the height. Just to show I'm well below the ground. And now rising up. So let's get the doxing protection going, because 3ds Max has shows my real name here in the here above in the corner. So well, had to use something to protect it. Here you see here you see my two models, one with the flat earth camera, one with the curved earth camera. Just to show it, the curve box is angled 1.5 degrees. No. So, and this is a line between both points, and you can see it a bit. It's curving upwards. This is where I got my value for the bulge. You can see it's measuring to the peak of St. Helens with the bulge, and this gray value here reads 3.069. Sorry, 3.069. That's I corrected the height of St. Helens Peak in this model to, well, get it better with one value. So this is the side peak. The length values are the corresponding heights, and the blue one is Mount Rainier with the 4.39. Same goes for the flat version, but well, it's not curved, so it's just the same thing without the bend. And just to show it that it's the same one, just bent. Get rid of this one. Wait a minute. Is the rest not bent? Oh yeah, it's well, that one. Oh, what's wrong? I guess the viewer height doesn't. Yeah, the viewer height doesn't align. The camera is. Oh, I didn't group the cameras with it, so. Yeah. You know what? Just up there. So, pretty much the same. Let's add the bend back in. So, yeah, I wanted to show you the other values for this model. So This is the observer height, 3.27 centimeters at 0.327 centimeters. This is the distance to Rainier, to St. Helens and the Sidepeak. It stops here. So, just right. The length of this whole block is 167 centimeters. I guess Rainier 4.39, St. Helens 2.539, and the Sidepeak 1.9882. So this is done. Get back to the just to verify it. No. So this tape measure for the height 0.327 centimeters. Isn't it? Yeah. There it is. This is the distance, again the distance to the to St. Helens and the Sidepeak. There it is. And again the value for Rainier. Just a bend. So back again to 2.539 for St. Helens, 1.982 for the Sidepeak. So the values are still the same, but the bulge is added and the camera goes a bit down because of this curve here. And if you're wondering why 1.4 degrees, why the angle is 1.5 degrees, just divide the 104 miles by 69, because every 69 miles is 1 degree. Or if you want it a bit with another method, just use the 167 kilometers and multiply them with 360 degrees and divide this by the circumference of the Earth. That's how I got it. So, well, and just show it again. Yeah. So This is the version without the bulge, like you can see. Rainier, a bit below the peak of St. Helens, and it's way higher than the side peak. And now the comparison with the bulge version. Yep. Mount Rainier a bit smaller than the side peak, and well, the St. Helen peak is way above both of them. So, this is the end. Thank you for watching, and have a nice day.